Hi everybody. Welcome to a combination of sections 3-5 and 3-6. Today we're going to talk about using partial products to help us solve larger multiplication problems. So before I begin showing you, quick refresher. The word partial means part, and product is the answer of a multiplication problem. So what I'm going to basically end up doing when I look for partial products is getting a couple different parts of the final product and then putting those pieces together to form the final product. Pretty simple how I do that. I have 275 times 6. So I'm going to have the 6 visit each place value above. And I'll show you a quick way that I like to do this to make it a little easier visually for myself. So I'm going to begin with my 6 and have it visit the 5 in the 1's place. In this case, 6 times 5 equals 30. I like to put the problem I did and then the answer to the partial product. The reason this is a partial product is because 30 is not my final answer. It's only part of my answer. Next, 6 times, now this is where it gets a little bit different. I'm not just doing 6 times 7. I'm actually doing 6 times 70 because my 7 is in the tens place. If I count by tens 7 times, it's going to be 70. So it's 6 times 70. The basic fact, 6 times 7 is 42. And I have 1 0 at the end to add on for a partial product of 420. Lastly, 6 times, now again, this 2 doesn't really mean 2. It represents the number 200 because I have a 2 in the hundreds place. I'm counting by hundreds 2 times. So this problem is really 6 times 200. 6 times 2 is 12. And I have 2 zeros at the end. The last step I want to do is add, in this case, my 3 partial products. And when I add my 3 partial products here, I come up with a final product of 1,650. Notice how each one of these is part of my final product? That's why these are called partial products. It's breaking this problem into smaller problems to make it easier for us to do. This example over here, same idea. 3 times 3 is 9. Three times, now it's a 2 in the tens place, so it's 20. 3 times 20 equals 60. Notice how I'm lining everything up nice and neatly so that it makes it a lot easier for me to add in the end. Next, I do 3 times 1, but this 1 is not truly a 1. It actually represents the number 100. So it's 3 times 100 for a total of 300. And my last partial product is 3 times 2. But again, as you've caught on, the 2 doesn't represent the digit 2, it actually represents 2,000 because I have a 2 in the thousands place, which means I'm counting by 1,000 2 times. So 3 times 2,000 is a total of 6,000. And you can see I've neatly organized all 4 of my partial products, and my last step that I'm going to do is add them. This is a little different than what we did in compensation earlier where we had to look at the sign above to tell us what to do. When you do multiplication this way, you're always going to add your partial products together to come up with the final product. So in this case, 9, 6, 3, 6. My final product after adding all 4 of my partial products is 6,369. Depending on how many digits you have in your larger factor up top, that's going to tell you how many partial products you're going to need to break your problem into to get your final product. Thanks for watching. I hope this helped you a little bit with partial products, and I'll catch you tomorrow.